This conference will now be recorded.
Shall we start the demo or we'll wait for a few minutes? Organize. Okay, let me start the demo. Share my screen. Just let me know if you guys are able to see. I hope you are able to see a blue screen. Others can respond. Maybe in the chat you can respond. And are you guys able to hear my voice? Are you guys able to hear my voice, guys? Someone, could you please respond?
Yes, and yeah, we can hear. Yeah,
Okay, thank you very much.
yeah.
All right. So today we'll do a quick demo on data science. Uh, so this would be a 2-month course. So I wanted to give you a very quick demo on how we use data science in the real world. Before that, myself is Siddharam, and I have close to 17 years of experience in IT. And in data science, I'm working for around 5 years or so. Before that, I was a big data architect. Apart from my regular work, I also provide training. I'm associated with Career ID for close to 5 years now. I used to teach Hadoop, Python, in data science. And coming to my educational background, I have master's from this Pilani and I'm pursuing my PhD in IIT Hyderabad. So this is about me. You will know more about me as we go deeper in the course. My prime, prime focus of this course is to make as much realistic as possible. Because most of our courses we see that there's a lot of focus or emphasis on modeling field. You see the courses anywhere in the internet or wherever it is. The focus would be more on the modeling piece, but when you get into the real world, there is a lot of work which is required on the periphery of the modeling piece. So today's demo will try to touch base upon aspects a little bit, and give you a perspective. And going forward, we will go deeper into many of these concepts and see how we can know more realistic data. I can give a name. Most of our sessions will be using this uh, blackboard or blue board kind of session. We won't be using a lot of presentation to make it more realistic, uh, more interactive. I try to choose this kind of a methodology. Practical data science is what we will discuss today. I recommend if you are not speaking, you could go on mute so that it won't cause any background noises. And if you have any questions, please put that in the chat window. I'll be able to see the questions and then respond accordingly. So thank you for that. Initially, right, I'll try to take a little step back in the history and then try to understand how we used to do data analysis. Um, one of imagine imagine a business, say a retail business. So imagine a retail business. If you are in US, you can think about Walmart, or if you are in India, you can think like DMart or Reliance, whatever. So there are these kind of businesses which are selling some basic products or something. And if you think like 20 years back, how it used how it used to do data analysis is it used to store the data into what we call as RDBMS databases. RDBMS databases, and typically these data sources are called as ODS, operational data stores, right? So purpose of these RDBMS databases is to store the information. These are operational stores. They store all the regular transactions which happen in the business, and then store it in RDBMSs. And people used to write SQL queries if you want certain data analytic um, information. So what is some of the data analytics information is like, for example, retail company is selling rice or sugar, or it's selling milk or some toothpaste or something like that. If I wanted to understand how many toothpaste were sold in last month, I can fire some SQL query on the table, and then it can give me the aggregated result of how many toothpaste were sold last month, and if I want to say the milk consumption in this week, I can still fire another query which can help me to understand the milk consumption for the week. Now this used to work 20 years back. This is how people used to write SQL queries to get some analytical information from the tables. But what happened is most of these queries, if they are running during the business hours, it used to hamper the performance of the table. So there is a database performance, and SLA is designed that the query should perform within a certain stipulated time. And because these databases were running throughout the day, say 9 to 5 is the business time, and if the SQL queries run during the same time, there used to be some performance issues. Now, to avoid that, 20 years back or so, people started doing something called as nightly jobs. So what are these nightly jobs? Nightly jobs are nothing but the same SQL query, the same job, which ideally used to run during the business hours. If you take US business hours 9 to 5, so Walmart opens in the morning and then shut down in the evening. During those times, you won't run these SQL queries. These SQL queries were scheduled at a later point in time where the databases were not busy. So this kind of phenomenon of data analysis worked again for many years. That you know businesses were running from 9 to 5, and these jobs used to run late in the night, say like 1 o'clock, 2 o'clock in the late in the night, and that was not creating any issues to the front end transactions. This was good. But what actually changed is there are two phenomena which changed in early 2000s. Is one is the internet adoption, and the second one is the geo expansion. Right, because of these two factors. Now, internet adoption around 2000, you might have seen that there are a lot of companies which were going online. People do not have the regular 9 to 5 shops, right? So the businesses are going online. There was penetration of websites and penetration of mobile apps, and because of which people can buy products, say like Walmart. I don't have to, if at all, I can still buy a product from online. I don't have to physically go and visit the shop, right? So that was one major phenomenon which changed the purpose of 9 to 5 businesses. And the other one was geo expansion. So the 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 companies were not limited to one geography. They kind of expanding to different geographies. The companies like Walmart, they were not limited to US, but they also opened their offices in or stores in Dubai. Their stores in Australia, their stores in Europe, and so on. So that is called the geo expansion. So because of the combination of internet and geo expansion, what happened is there was no lean time for the nightly jobs to run. Now, what do I mean by lean time? Lean time in sense the time at which we can say that it will have minimal impact to the ODSs by running the nightly jobs, right? So there was no such lean time, and what happened is, people created a concept of warehouses. Now, warehouses are nothing but the exact copy of the tables, right? The front end tables, the exact copy of the tables, by doing some kind of transformation, by doing some kind of extraction, then transformation and loading. So the process is called as ETL, extract, transform, and load. It means that you extract from the source tables, you do some kind of transformation, joins, and whatever, remove the unwanted information, and then push it into backend storages. So the beauty of data warehouses is that one, it provides the decoupling, right? So you have source tables, which are the operational data stores where the actual business is happening. And there are these data warehouses which are decoupled from the source tables so that I can run my SQL queries on my data warehouses without impacting the front end source, right? So what happened is that these data warehouses is basically decoupled from the source tables, and what happened is that they actually are 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 kind of providing an ability to run any queries even during the day. So people used to run queries even during the day, which will not impact the ODS. One other major advantage data warehouses brought is that they have the ability to store historical data. So if you see ODSs, they are like more real time. That means that as of today, whatever is the data you can see in the ODS table. But data warehouses also have historical data. I can go back in time. I can see what happened last year. I can see what happened last month. So they have history of information which is stored. So you could also do this kind of historical comparisons on the data warehouse, right? I want to compare what is the sale of rice uh, sold in last year and this year. I can still do that by doing some queries on database. Now this was a major trend change and in data analytics, and lots of companies you would have seen even now they have huge data warehouses set up where they do a lot of data analysis, and they can use this for doing a lot of data related work. Now there is a trend shift in the early 2010s, I would say, is that so these data warehouses are only storing structured data. Okay, so data warehouses are primarily used for structured data. So what do I mean by structured data? Structured data is nothing but you have table kind of structures, you have rows and columns, proper defined information. But when it comes to unstructured data, there is a lot of penetration of data with respect to images, videos, text in the early 2010, where people also want to store that kind of information for extracting uh, some kind of metric, some kind of insight. Now, when it comes to unstructured data, these data warehouses were not really good. So people have to go and build something called as data lakes. Now, what are data lakes? Data lakes are combinations of systems which use distributed computing like Hadoop. Then you can use some of the cloud providers. You could use what we call as what we call as other kind of cloud providers like Azure and so on, right? So what these have done is they have provided the ability to uh, basically store large volumes of data in unstructured format. Now, what could be the format? The formats could be images. It can be images. They can be video formats, right? So there can be text. Now, text in sense it can be real text or log information, whatever, right? So different text formats. There can be some sensor information, like some sensor data is being sending. So I'm just roughly drawing, right, some sensors. So so a lot of things like IoT and things like that, they can send a lot of sensor information. So it can be images or some text or something, or it can be some videos. All this kind of information now we have an ability to store in these data. Now you see this is a lot of work, and this entire piece of work, setting up the data warehouses, setting up the data lakes, having cloud-based data lakes, and doing the data ingestion, ensuring the data is available and producible by other sources. This entire work is taken care by data engineering team. So the company might have a data engineering team comprising of cloud developers, Hadoop developers, ingestion developers, maybe like ingestion developers like Kafka. There are some kind of tool sets like Scoop, Flume, and other kind of tool sets. All those kind of different ingestion technologies will be there to ingest data into the source tables so that we can use that for our regular day-to-day work. Right? So this is the role of data engineers. There are again a lot of jobs here. You might have heard about big data engineer roles. This is where your data engineering comes into picture. Now, once the data engineering is done, now this is the raw data. So people do something called as data transformation or EDA or data transformation. So the next step is to perform this data transformation or EDA. What this EDA or data transformation does is try to understand the data and try to construct information which can be consumed by my model, right? So there is a lot of merging of tables, joining of tables, cleaning of data, because this data is more in a raw format. I am dumping a lot of textual data, I'm dumping a lot of structured information, videos, images. All these are in a very raw format. So I have to perform a lot of data transformation steps. You might have to remove unwanted columns. You might have to fill in the missing values. You have to do a lot of pre-processing on your data so that data is clean. So if you give garbage to your machine learning models, your results will be also garbage. So you want to clean the data. You want to keep it in a very clean format so that your machine learning models will perform really well. So that step will be taken care by the data transformation. EDA is also called as exploratory data analysis. Exploratory data analysis will give us ability to perform some actions in terms of visualizations to understand how my data looks like. How is my input data looking like? Is there some bias ingested in the input data? Is it considering all kind of possibilities, combinations, and so on? Which kind of columns are important, which are not important. So all those things can be visualized using ED. So once this entire activity is completed, the outcome of this activity is to identify right features. Features are nothing but the input columns which are helping us to do some kind of prediction. So output of this would technically yield us to something called as feature stores. So feature stores are nothing but these are kind of output output areas where you basically extract information and then store it in some kind of feature stores. Now, what this feature stores will do is you can in the future you can go and search the feature stores instead of getting the data from the data lake. You can directly go and query the feature stores, which will give you more cleaner information, and you can directly consume the features for doing your modeling. Once feature stores, data is stored in the feature stores, the next step is that you perform something called as modeling. The next step is called as modeling. Modeling is the kind of heart of the entire data science pipeline, where you try to test a lot of algorithms. Now, there are a lot of algorithms, like there are structured, unstructured related algorithms. There is supervised, unsupervised, semi-supervised algorithms, reinforcement learning algorithms. So all these different kind of algorithms, what they will do is they will try to look at the input data and then try to compute algorithm in such a way that it can get the patterns of input and output and predict my output in a very quick manner. That we basically call it as modeling. And if you see, most of the data science courses focus very heavily on the modeling piece, right? They are very focused on A, B, C, D, different types of algorithms, how they are performing, what is the accuracy of the algorithms, and so on. But as you see, this is just one small piece of the entire equation. We will try to see like what other things we need to create to have much more insights on the data science, end-to-end data science. Now, modeling is one small piece of the equation. So once the modeling is completed, we basically do something called as serving or deployment using two methodologies. One is batch deployment. Batch deployment is where you serve the model using a Jenkins pipeline, where the entire model will be retrieved and you can compile a job and then job gets submitted. Either you can submit the job in containers over Kubernetes, or you can submit the job on some kind of a cloud provider, or maybe you can submit the job elsewhere, right? So one is the batch mode. Batch mode, what it will do is it will run the job, it will compile the model, and then you can use a REST-based API for creating an API endpoint. And once this is done, these models models get saved into some kind of cloud provider. Now it can be a artifact storage like Nexus or Artifactory, JFrog, Nexus or JFrog Artifactory, or it can be some kind of cloud provider like AWS or Azure. Azure. Now what this will do is this will compile the job, so it runs a Jenkins pipeline. Jenkins pipeline is run basically to your take all the metrics and then basically compute all um, um, pre pre-processing steps, like it will do source code validation and all that stuff, and then finally a model will be created. Model is nothing but an executable of your modeling, right? Suppose you are running algorithm, say like decision tree. Forget about what this algorithm does or whatever it does, but just imagine that there is one algorithm we are running to find out the say like to find out whom should we give loan, right? So if I'm running that algorithm, then what happens is that basically uh, runs the output of your modeling, and then you can compute your outcome, and you can store that outcome into some kind of cloud provider. So once you're storing the model, typically this this piece is called as a REST endpoint creation, which is also created using a REST-based pipeline. So now this is a batch-based pipeline, but you can also create an online, or what we can call as a REST-based pipeline, which can help you to do the modeling and then get you the direct API. And using this, what you can do is you can have a front end system. Suppose this is a front end website of some bank, ICICI bank, where it is asking for loan applicant information. It asks for name, address, salary, and bank balance, loans and other liabilities. So it asks all the questions, and then it can feed the information to the API. And once the API responds, the API is having the ability to predict whether the person will get the loan or not. So you can create this application using any front end thing like Angular or React application, right? So it can be run on Angular or React application, but it will consume this API endpoint for predicting whether the person will get a loan or not. Once the application predicting that, okay, Sitaram, you get a loan of say like 5,25,000. So this application, front end application will show another screen that congratulations Sitaram, you are eligible for 5,25,000, and click this link to start the dispersal or something like that. Right? So that's how the application can be created. Another piece which is very important in the recent times is what we call as monitoring. Now, monitoring is very important because you deploy these models in production, but now you need to know like how these models are performing, right? So there is certain things called as data drift or concept drift. There are things like explainability, um, and there are things like fairness and so on. So there are a lot of other things which we need to consider when the model is deployed, because is the model performing in the same way while we were doing what we call as training? Is like when we are doing the development of the model could have performed in certain way by which we decide that this model can go into production, but is it the same behavior which it is performing in production also? So to understand that, we have to monitor the model in real time and then see whether the model is performing as per the expectation. And in very highly regulated companies, for example, banking companies, insurance companies. So in these highly regulated companies, you also need to do something called as explainability and fairness. For example, what if I'm saying a person is getting loan, what are the contributing factors by which I can say that this person gets loan, right? So how can I say that this person gets loan or this person gets rejected? Because they can also sue a company based on their decision making. So we need to clearly have a pinpointed information that what is the cause of rejection or what is the cause of approval for certain outcomes of my AI model. So to do that, we have something called as explainability, which will tell that because of your bank balance is less than so and so, because your poor purchase history or more liabilities. These are all the reasons for the rejection of the loan. So it should be able to clearly pinpoint and say what is the reason for rejection. Coming to fairness, fairness is also an important metric, because fairness says that are we treating, is the model not getting biased based on gender, demographics, and other kind of parameters. For example, if there is a male who is opting for loan, with provided their salary and bank balance, everything is same, and a female opting for a loan, which is having same bank balance and salary, uh, are they treated differently? Right? So sometimes there can be some kind of bias induced based on many different parameters, but we need to reduce that kind of a bias. So we need to find out what is the bias of the model, so that we have to balance a lot of things apart from the accuracy scores and other kind of scores. So there are fairness indicators based on which we can identify whether the model is fair and can adjust it accordingly so that Sorry. So I adjust it accordingly so that it can get more fair modeling behavior, right? So as you're seeing, we quickly spend around 40 minutes now. So as you're seeing that this is the entire scope of data science, but what unfortunately people talk is only this small piece, the modeling piece. But you see that there is a lot of work which we need to do with respect to how we do data science in the real world. So our course focuses on that. We try to focus on how do you perform data transformation, the concept of feature stores, how do you build batch-based pipelines, how do you build REST APIs, and how do you create monitoring services, and apart from the modeling, right? Apart from modeling, we talk about all these different things. We would also see like how do you do deployments on AWS. We will also see like how do you perform Docker-based deployments on AWS so that you get a clear idea about how this data science works in the real world. All right. Any questions on this? I'll take a small pause to check if there are any questions. Me one. Any questions? I hope you guys are able to follow. You can use the chat window to answer any questions, to ask any questions if you don't want to speak. All right, I'm not seeing any questions. Did you guys follow the entire path guide? So how it started, what are the key areas, and the machine learning piece of it, and the model monitoring and serving part, deployment part.
Yeah, yes, and yeah.
Thanks for responding. So, guys, other guys, any questions? If you don't have questions, then we can wrap up the class. If you have any general questions, also we can discuss.
So can you discuss about the job profiles actually, like data on data science, right?
Yeah. Primarily, there are two major job profiles, two or maybe three, we could say, but two major profiles. One is the data scientist role. Data scientist role is the central piece. This piece of work will be done by data scientists. They will be doing the modeling. They will be doing the data transformation, storing features. This part of work will be done by data scientists. So depending upon the experience range, there are junior data scientists, senior data scientists, principal data scientists, like that. So different roles will be there. But
Okay.
coming to this piece of work, we call them as ML engineers. So if you see, ML engineers will have connect with the data scientists. So they work hand in hand. In small companies like startups or smaller companies, both of them will be one person. The person will be data scientist as well as ML engineer, but the skill set of both of them will be little different. Data scientist is more of a qualitative kind of skill set, more in Python, more in modeling and work like that. But ML engineers is basically they also have understanding of Jenkins. They know how Docker works, how to deploy models on Kubernetes or one of the AWS services. They will have understanding of how to build APIs using Flask or Django or any other kind of framework. They also build tooling which can do monitoring services and so on. So if you see this piece of information, this piece of work will be called as ML engineer, and this piece of work will be called as data scientist. Depending upon the company, you would get either of the roles. Some companies will have data scientists do everything.
Okay, okay. So Python is a prerequisite, right? For
Python, yes, Python is a prerequisite for this. So we expect that you have some understanding of Python. Even if it is a basic understanding, it is okay because during the course we will be going through Python specific for data science. We need a lot of libraries and other kind of understanding of Python for data science. So that we will be knowing. We will be knowing in the coming weeks. And eventually, you'll get comfortable with how to write programs in Python in data science. That piece we could cover.
yeah, okay.
All right. Any other questions, guys? All right. So if you don't have any questions, we can close the call. Sessions would start on Tuesday onwards. Uh, Timings would be 6 a.m. to 7 a.m. IST, uh, Indian Standard Time. So depending upon your time zone geography, you can map it accordingly. So that's the time classes would be running. You can talk to the coordinators if you have any other questions. If there are technical questions, they'll reach out to me. If there are other questions like what is the timing and course duration or whatever, so they'll be able to answer. Right?
Yeah, sure,
Thank you.
Sitaram. Yeah, yeah.
Have a
Thank you so much.
happy Saturday night, Sunday. Thank you. I'll talk to you later. Bye.
Yeah, thank you so much. Yeah.